Hey, everybody. Thank you for coming tonight. My name is Preston Staley, and welcome to the Gateway Remote Telescope lecture demonstration. This is number 4 on July 8. We're really excited to have you all here with us. I'm here with my esteemed colleague, Stan Honda, chairman of the GRT committee, and our esteemed president, Alfredo Villegas. We're really excited to have you guys here. Tonight, our agenda is going to be as follows. We're going to, Stan's going to say a few words about what's going on with the scope, and Alfredo's going to give us some quick update on what's new with the scope. And then we got 2 guest astrophotographers with the club here tonight. We're really happy to have with us. Andrew Warner is here, and he's going to talk about his latest image of the Iris Nebula. And Garry Schnettler is here, and he's going to talk about the Crab Nebula that he's just taken an image of, and they're all really cool. And then the woman, the myth, the legend, Irene Pease is going to be with us. Irene is a physicist, and she's an educator, and she's just been a AAA member for a long time. I'm not sure how long, Irene, and also president of the club. So we're really thrilled to have Irene with us tonight. And so that's kind of what's going on here with our agenda tonight. So I'm going to move it on to Stan Honda, and he can give you an update on what's going on with the scope. As I hear people coming in, all those. Can you guys hear the bell ringing every time? Does everybody hear that?
Yes.
My goodness.
Yeah, we love it.
Well, it's 41 people so far. Thank you all for coming. Stan, take it away.
All right, thanks, Preston. And we've got some nice updates for the Gateway Remote Telescope. And I think most of you have been to our lecture and demos. If you don't know much about the Gateway Telescope, go to the Gateway page on AAA.org. You'll see a description of our setup, the remote telescope setup in Fort Davis, near Fort Davis, Texas. And then there's a link to the Gateway Gallery. You'll see a whole bunch of great images that done by a lot of people who are participating with the project. We had a really nice equipment update in April. I went out and helped John Kasinowicz, who owns the rig, install a filter wheel that we bought for the AT60, the smaller telescope with the one-shot color camera on it. And thank you very much, Andrew Warner, for donating I think it's a quad band filter for that filter setup. And Andrew can go into more detail about what that filter is, since I don't really know too much about it. We've got a great, I think, number of people. We've got 47 paying tier members for the different tiers, the telescope operator, target selectors, and data subscriber. And we have an additional 35 people that sign on as Gateway observers. So a total of 82 people who have really shown extreme interest in the project, which is really good. And we've got a whole bunch of objects in our Google Drive that the 3 paying members can access. I think we've got a total of about 63 objects now between the 2 telescopes, the AP175 and the AT60, and then the data that we have from a Cerebolo telescope that we're slowly putting onto the Google Drive. And we're looking forward to seeing more pictures throughout the summer from everybody, and I think everything is going pretty well so far. So I'll let Alfredo talk a little bit more detail about some news about the telescope.
And Stan, you hit the record button, right?
Yes, we are recording.
Okay, just checking.
So welcome, everybody. Happy to have everyone here. As Stan said, we've had a lot of success so far with the Gateway project. And, just to give you some more detail, I mean, we have effectively 2 scopes operating and a 3rd scope that we have data for. In total, so far, just to give you an idea, on the AP175, which is the 7-inch refractor, we have 17 nebula, 10 galaxies, 2 clusters that we've uploaded. All of these we've uploaded to the data subscriber tier. The AT60, which is the scope the club owns, we have 5 nebula, 4 galaxies, and 5 clusters. And there's a bunch more that we're going to be uploading there too, probably another 6 or 7. And with the Cerebolo, we have 5 nebula, 5 galaxies, and 5 clusters. And like Stan said, we'll be uploading some more. In total, we have something like 450 gigabytes that we've so far collected. we're on track, I think, to probably hit a terabyte, by November, our anniversary. And there's a couple of new things on the horizon. One of the things that we're thinking about doing is actually launching a Gateway South. One of our club members, and Antoine Ribaud, who actually is the club member who donated our AT60, has an Astrophysics 130 Starfire mounted on a 10 micron 2000 mount in Chile, and he's willing to give that to the club just for the cost of running it. And so we're contemplating doing that. So far, the Gateway project's been all self-funded by club members, so it hasn't cost the association a dime. If in fact, we actually have a surplus from the first year so far running it. So we would do the same thing for Gateway South. It would be a similar structure where we would basically have people pay $500 to be operators, $150 for target selectors, and then the $30 level for data subscribers. Remember, if you're a data subscriber, you get access to the data forever. So that this data that we're collecting is going to remain on the club's Google Drive for as long as people want it there. So even if you join next year, you'll still have access to all the data we collected. Plus, if we do the Southern Scope, you'll have data for that. So we're thinking about doing it. I think we will do it. It's just a question of timing. One of the things that I would like to kind of just throw out there and ask for help is, we are an all-volunteer club, and doing this stuff does take a lot of time. It takes a little bit of effort. So, if anyone would like to volunteer to help us out, in particular, one of the big obstacles we have with doing the Southern Telescope is actually just having someone help us with the data and just administering the data and just keeping track of it, because we're starting to already kind of hit our wit's end with the data that we've collected so far. So if anyone out there is tech savvy and knows how to use Google Drive and kind of would like to do that, that would be a real big help for us to have some people willing to donate their time. It's not a lot of time, but just having someone out there to do it, that would be really great. I think that's all I really have. I'll throw it back to you, Preston.
Yeah, I just want to say a couple of things. First off, when it comes to this data thing, when we first started this project, we weren't sure what was going to happen, but now it turns out that we're the dog that caught the car. We've got it's been so successful that we really need help trying to get this some of this data organized. And also, Alfredo, if you could just explain a little bit about the Saravala data, because that's not our scope, and just because we have two scopes, we have the small one, the big one, and then we have this data. Go ahead.
Yeah, so when we entered into the deal with John on the setup in Texas, there was a legacy amount of data collected by a Saravala 300, which is basically it looks like a large SCT, but it's truncated. It's a little shorter, so it's a very fast, wide field, higher focal length scope. I think it's like 1400 millimeter focal length, and it's just excellent optics. It's probably I think it's like a $40,000 telescope. So it's a really nice telescope. And that telescope had a lot of data that was already there. And as part of the deal with John, we bought that data. So that's data that we now have as well for data subscribers. And we've been basically leaking that data out every month. The reason we haven't posted all of it is just because, again, it's a volunteer thing to some degree. And also we wanted to kind of give other people who paid a little more time if they wanted to look at that data. But we will have all that data out by November, which will probably be something like 40 targets, I think, that are in the Saravala database, something like that. So
yeah, I think almost 40.
Yeah, these are amazing images. So for those of you just checking in, we've heard a number of people come in. So we're the agenda for tonight. Next is we're going to talk to Andrew Warner about his latest image, and Garry Schnettler about his latest image. And then Irene Pease will be here with us, and she's going to go through images in our Gateway gallery. There's 13 images this time around, and these images are up for the Image of the Month honor. And so at the end of this presentation, when Irene is through presenting these images, we'll have a vote, and you guys, you viewers at home can vote on what your favorite image is, and that'll determine the outcome. So now we're going to move on to Andrew, and welcome, Andrew. Thank you for coming. And why don't you tell us what you've been shooting and how you did it and what's going on with it?
All right. Thanks, Preston. Hi, everyone. I'm Andrew Warner. I'm one of the GRT operators. The latest image I worked on, which I'll be presenting briefly on tonight, is the Iris Nebula. I just have a PowerPoint presentation I threw together that I'll share with everybody. So the Iris Nebula, otherwise known as NGC 7023, or I should say the opposite, NGC 7023, otherwise known as the Iris Nebula. So just briefly, and non-comprehensive overview of kind of what goes into choosing a target when we're deciding what to image. First of all, we want to maximize our time and pick something that's going to be in the sky, ideally all night. The longer in the sky, the more images we can get, the better quality image, the fainter the object, so on and so forth. So something that's in the sky all night is ideal. Position in the sky. So something that's really close to the horizon isn't ideal. So you want it to be at least 30 degrees above the horizon. Moon phase, you don't want, if you're shooting broadband targets, something that's kind of faint. Ideally, the moon wouldn't be too bright. New moon is the best. Crescent moons are okay, but as you start approaching the full moon, it reduces contrast and makes your ability to image fainter targets more difficult. And then lastly, imaging capabilities, specifically equipment. So what kind of telescope you're imaging with, and what's the focal length, and what is the framing of your target going to look like. The Bortle class or sky quality meter. So the darker the sky, the lower the Bortle class, the higher the SQM. The better quality data you can get, the less integration time you can, with less integration time, you could get a better quality image as opposed to a more light polluted area, and you could also image much fainter objects. So if you're imaging from a higher Bortle class area, you might want to pick a target that's generally brighter than from a low Bortle class area, where you could get something that is very faint and typically not obtainable from a city or a suburban area. So when I shot the Iris Nebula, my dates that I was imaging on were June 4th and June 10th. Which both had a crescent moon with an average of 11% illumination. Those nights, slight variations between the nights, but the sun set about 8:50 p.m. Night was between 10:30 and 5:15 a.m., which gave about 6 hours and 45 minutes of ideal imaging time. And sunrise was about 6:50 in the morning. The equipment I used, so the scope I chose to frame up the Iris Nebula was the AT60, which is a f6 360 millimeter focal length scope, so fairly wide field of view for deep space astrophotography. A lot of people that image the Iris Nebula choose a longer focal length to kind of focus on the iris, but I was particularly interested in the dusty region around it. So I thought that the AT60 would have been perfect for that. The camera that's attached to this is a ZWO ASI 2600 MC Pro, which is a cooled one-shot color camera. The mount is a 10 micron GM 3000 HPS, which is a pretty beefy mount and can obviously support our bigger AP 175. Sorry.
Well, as long as you're paused, could you use your cursor and just outline the scope, because we're seeing the big scope.
Sure.
A lot of people might not know what scope you use. It's a littler one right here on the side.
Are you able to see my cursor?
Yeah.
Okay. Yeah, this is the bigger AP-175, which is, I believe, around 1100 or so millimeters focal length. And this one is the AT-60, which is what I imaged on, which is 360 millimeters focal length. So big difference between the two. This is the camera. This is an automatic focuser. And then it's all sitting on top of the mount. Not pictured, I think it's on the other side, it's the guide scope. Were you going to say something, Preston?
No, that's cool. Thank you.
And then also not pictured is a computer that we log into remotely and control everything with a program called Nina, which is an open software used to control the astrophotography rig and kind of set all your parameters. So this is a screenshot from Nina. It's the framing wizard, which you could type in the name of your target, and then it shows you an outline of what your framing will look like. And then, so this is the Iris Nebula in the middle, and then some other objects surrounding it. And then once we frame it the way we like, we send it to a sequencer. This is not from the night I shot on. This is from last night, actually. So this graph over here won't look the same, but it's essentially similar, where you could see this is twilight, civil nautical twilight. This is astral twilight, and then everything in black is night. And then this is showing the ascension and descension of your target, and kind of where it crosses the meridian here. And then this line here is where we are right now. Then you said essentially all your parameters, how many images you want to take, how long you want each image to be, filter if you're going to use a filter, dithering, and then you start the sequence. So I was able to obtain 210 images over those 2 nights at 180 seconds each, which gave me about 10.5 hours worth of images to work with. And then I obtained calibration frames, dark flats, and then I used PixInsight to process everything. And this is the image. So yeah, that's that. You could see the Iris Nebula in the middle, a bunch of dust around it, and a few other objects, and just an attestation to the dark skies of where the GRT is located in Fort Davis, Texas. You know, it was a decent amount of integration time at 10.5 hours, but it's still a lot of faint dust that I was able to pull out, which I was very impressed with. And then I removed the stars just to kind of highlight the dust a little bit.
Yeah, Andrew, that's great with all the dust in there. Just sorry to interrupt for a second. George Priotiasa has a question.
Sure.
George?
I was going to ask about Nina and Meridian Flip. How does it handle? And more generally, you set this up and then you go to bed, or do you have to babysit it, check from time to time?
Essentially, well, it handles the Meridian Flip very well. You know, everything's set up in a way where the wires don't snag. There's no risk of it bumping into the mount or the pier that it's on or anything surrounding it. And then after it flips, it performs another autofocus sequence and essentially continues uninterrupted. I typically—
And the centering too, I mean, does that center, right?
Yeah.
Frame rotation.
So it's one of the parameters you can set where after it does the Meridian Flip, it'll recenter the target and does a quick plate solving just to make sure that it didn't deviate at all. And then if it has to, it'll recenter it automatically. And it also does that at the beginning of your sequence as well. And if you can see right here, some of the parameters we set are slew to target, center on target, and that, you know, you can watch it live where it does a whole plate solving sequence. And often it needs to make little adjustments, but it's pretty accurate. And then what was your second question? Sorry.
Well, in general, if you have to, you can go to bed or you have to babysit, you know.
Yeah, I'll watch it for maybe like 10 or 15 minutes and make sure everything's going well. So the observatory has a roof that opens and closes automatically based on the weather, so we don't have to worry about anything getting damaged if the weather's not cooperating. And then, aside from that, if clouds roll in, I don't think it's personally worth staying up and waiting to see how the weather is, where I could just review the images in the morning. So I go to bed unless I'm working a night shift, which I do sometimes. Then I'll kind of look at it in awe all night.
Just as a funny aside, George, all this is very easy to log in. You can log in and control this telescope from your PC. You can do it from your iPhone. You can do it from your laptop. I've logged in and controlled this telescope from on the plane with Wi-Fi access, from my car, which I probably shouldn't be doing, from my home, obviously, from work, from the subway, right? So, I mean, you can basically log in and, do all the stuff you want to do. So like Andrew said, you can just set it and let it run and not even bother to look at it, or you can be as hands-on as you want. It all depends on your own personality and what you'd like to do. But it's all set to be completely automated. If you wish.
Freeman, do you have that program when you're looking at it at work that you click it goes to a spreadsheet in case your boss walks in the room?
I personally
I just told my door person.
Okay.
One other quick question, is it you can only choose one of the two telescopes to run at a given time, right?
No, you can run them both simultaneously. And when we first set this up, we had a slight misalignment between the two telescopes, but now they're pretty much perfectly aligned. So you can run them both simultaneously, and we've done that a couple of times. The field of view actually on the AT60 versus the AP175 is not that much more, because the camera on the AP175 is a bigger chip camera. But if we had a full frame camera on the small scope, then you'd have a much wider field of view. So it lends itself. Let's say you wanted to, shoot a comet that happened to be passing, a nebula. You could basically aim the big scope at the nebula, and with a small scope, basically just take frames at the same time. You wouldn't be able to. You would have some lost frames on the small scope, because obviously the big scope, you wouldn't be able to dither, but you could shoot them both at the same time. Yeah.
Well, that's great. Andrew, why don't we move on, because we're pressed for time here. Thank you so much. Let's go on to Garry. Schnettler is here. Schnettler, correct? Am I pronouncing it correct?
Schnettler, 10 letters, 2 syllables.
Okay. Thanks for coming tonight. We're really looking forward to seeing your image. Why don't you tell us what's going on with it, and take it away.
Sure thing. Thank you. I'm going to share my screen. Can you see this okay?
Yes.
All right, so I don't have a PowerPoint, but I was going to show you some things. So this is a program called Sky Safari that I use to plan my nights. My image is the Crab Nebula. So you can see here, this is back, if I click on time, back in January. And so you set the date, and then this rectangle represents the 175 meters. This is the big telescope that you saw in the picture, with the reducer and the 16,200 FLI camera. So this is the field of view you get. You can see the Crab Nebula, even with a big telescope like this, it's a pretty small object, but you can frame it up. And I love this program, by the way. You can go in here to scope display, and this is a little one, the AT60 ED with the 2600 camera. So you can see it does have a bigger field of view. It's not tremendously bigger, but it's bigger. So I use this to plan my nights, and I skip around, and this is a 7 p.m. So I say, well, where's the object going to be at 8 p.m., 9 p.m., 10 p.m.? And kind of say, well, if it's going to be there all night, it'd be a great thing to image. And I set it all up in Nina, just the way Andrew did. Moving on, when you collect the data, it shows up in files like this. They're all FITS files. So for this one, I imaged in the oxygen filter, the hydrogen filter. There's B for blue, R for red, and so on. And if you want to click on any of these, you can see, sure enough, this matches what Sky Safari showed in terms of the field of view. There's the image there. So for this particular object, I got 72 exposures, which total 7 hours. So it was 2 hours of RGB and 7 hours of hydrogen and oxygen.
Huh.
From there, I took it over to PixInsight. You can see the same thing, same field of view. PixInsight allows you to do things like take out this vertical line, which comes from the camera using something called cosmetic correction. And then from there, once I had it all processed, I got this image. So I thought this came out pretty neat. The telescope is fantastic. The dark skies are fantastic. So as a result, if you zoom in, you get a pretty detailed image. This the colors here are not they're not true colors. Since I was using narrowband, this is predominantly the HOO. I'm sorry, hydrogen, oxygen. The stars are true colors, but the nebula is processed using something called the Forax palette, FORAXX. So this is a dynamic narrowband thing that you can run. There's a script for it, or you can run the pixel math. The pixel math is down here. It's a bunch of expressions. So it's really kind of complicated, but it gives you a different set of colors than you would normally get with the HO image, which I think is pretty pleasing. I want to say a few things about the M1 Crab Nebula. So this thing was not here 2,000 years ago, but in the year 1054, there was a supernova, and Chinese astronomers noted it. Actually, a lot of Indian tribes noted it in their hieroglyphics. The Chinese astronomers recorded that this thing was visible during the day as a supernova for 23 days. So during the daylight, you could see it. It was so bright, it was 4 times brighter than Venus. The magnitude was like, I think -6. Yeah, -6 magnitude. Now the magnitude is 8.4. So it's very dim. When I look at this object in my telescope at home, I can't see anything. But in the dark skies of our Texas observatory, you can capture an image like this. In the middle of this right now is a neutron star that is spinning crazy fast, 30 times a second. It's just like pumping out crazy amounts of energy. And so that's what lights this thing up and makes it such an amazing target. So that's my summary of Crab Nebula. Any questions?
Oh my gosh, I got 100 questions. Can you? So let's talk about the palette you used, because for I think for some people, we're looking in the electromagnetic spectrum, and we see the visible part of it, the RGB, as you mentioned, the filters that do that, but also you mentioned oxygen and some other elements. Can you talk about where that lies in the spectrum and how that affects the image?
Sure. So traditional cameras capture RGB, red, green, blue. I used to think that was weird because the primary colors are red, yellow, and blue, right? But it turns out that our eyeballs have cones in them, and they're RGB. So our eyes do RGB, our monitors are RGB, our Nikon and Canon and cell phone cameras, they're all RGB. And those are, it turns out the chip is actually just sensitive to black and white, and they put little tiny filters on top of every single pixel. So if you have a 16 megapixel camera, there's 16 million tiny little filters called the Bayer matrix across each one. So each pixel is a particular color, either red, green, or blue on a color camera. So that's where that comes from. And traditional pictures use RGB. For astrophotography, though, with a mono camera, you can do, I guess you can do it with the RGB camera too, but specifically with mono, which is what we did here, you can pull out 3 frequencies of light. One is hydrogen, one is sulfur, and one is oxygen. And so when if you remember from chemistry class, when your electron changes from one orbit to another, it releases a photon. And these are the photons we see. So in particular with hydrogen, when it changes from one level to another, you get these hydrogen alpha emissions. There's also a hydrogen beta, which is at a different frequency. Oxygen is at another frequency, and sulfur is yet another frequency. If you look at a astronomy website that sells gear and you look at the filters, they typically would show you the frequencies. I don't have them memorized, but the hydrogen is in the red spectrum. Sulfur is also red, and then oxygen's blue-green. So you could just process them that way. And if you do that, it'll be kind of a reddish image with some blue-green in it. But NASA came up with the Hubble palette, and they did it for scientific reasons. They actually have a lot more filters like nitrogen and a whole bunch of other ones. And they wanted to show every molecule as a different color. So they could say, if you see a lot of this color, then you can tell what the molecular makeup is just by looking at the colors. So there's all these things going on. And the 4X palette is just a particular way of processing the hydrogen and the oxygen using some fancy formulas to kind of make it more exciting and bring out some dynamic looking images.
So in other words, because we see as humans only in RGB, basically, we're arbitrarily assigning other colors to these spectra that we can't see, part of the spectra we can't see.
Since you're asking about this, I'm going to just really quickly show you that I have a one here. So this in RGB is what the Crab Nebula looks like.
Okay.
The all this white stuff here, I feel like gets in the way. The narrowband hydrogen and oxygen cuts through this and lets you see more details.
Really cool. Any other questions that anybody has? If not, we're going to move on because what time is it? 8:33. So we've got 13 images.
Somebody has their hand raised, George.
Oh, okay. Someone had a hand up. Go ahead, whoever it was.
I think that was George's, his previous.
Yeah, I
question.
gotta put it down. I don't know how to do that. Let me.
Okay.
No.
Got a
Alright.
strong arm, George.
Thanks, guys.
All right, so we're going to move on. Excuse me. Let me get out of this first. And like I said before, we're really pleased tonight to have Irene Pease with us, the woman, the myth, the legend. She's been a AAA member for a long time. She's been the president of the AAA. She's a physics teacher, an astrophysics educator at the American Museum of Natural History and the Hayden Planetarium. And we're really thrilled to have her with us tonight. And so welcome, Irene, and take it away. And I guess, Stan, you're going to show some of the images, correct?
Yeah, I'll share the images. Irene, I'll just tell you what the image is and then tell everybody what the image is and who did the processing, and then you could take it away with the description.
And then we're going to leave about 10 minutes at the end for people to go through the images and vote on their favorite, and we'll have an image of the month. So that's what's going on.
Okay, here's the Medusa Nebula and processed by Ed Rojas.
So so you said Medusa, right? Yeah, Medusa.
Medusa.
Yeah, so I just have a few notes for these. So this is an older planetary nebula. So we're used to seeing planetary nebula being fairly round or spherical. And you can see this one's starting to fade quite a bit. So it's been around for a while, getting towards like the more diffuse part of its life cycle. But these are short-lived objects. And so this is what our sun will do eventually. It'll poof off its outer layers, leaving just the kind of white dwarf core in the center. These are only in existence for like a few thousands to tens of thousands of years. So again, relatively short-lived. This is over in the constellation Gemini, about 1,500 light years away, about 4 light years across, which is getting pretty big for a planetary. They tend to be, relatively small. And I just have a note, some of the colors in here, I think are maybe a little reminiscent of what we were just hearing in Gary's presentation about like some common elements. So we get greens from the oxygen and the reds from H alpha, the hydrogen alpha, 656 nanometers. If you take any of my astronomy classes, I harp on that. So, some nice colors in this planetary nebula.
Here we have NGC 3718 and 3729, processed by John Williams.
Okay, so probably people recognize this as a pair of galaxies. This is up in the Ursa Major. It's actually part of the Ursa Major cluster, which is part of the Virgo supercluster that we're also a part of. So not the main Virgo cluster, because it's in Ursa Major. So we have a barred spiral that we're seeing in there that's a little bit further away, and then a possible lenticular or spiral. Had conflicting ideas from the sources I was checking. Some possible gravitational interaction that could have caused like some of that kind of swirling that we're seeing for the one on the left. but they are a bit further away. So different sources had different numbers, but some sources said that they could have possibly had some interaction in the past to kind of spread the left one out like that. So interacting galaxies, possibly interacting galaxies. I'm going to call this one. Am I allowed to have favorites while I'm doing this?
Sure.
Okay.
Why not?
Because I was really excited to see the list. This is kind of a favorite. I was NGC. Oh, sorry. Go ahead.
Oh no, you're right. NGC 2264. I think it has a much more colorful name that you could tell us. This is David Gluchowski who processed this image.
Irene, you're putting your thumb on the scale. I don't know.
Oh, well, I have lots of favorites, not just favorite objects, not favorite images, because this is my first time seeing these images.
You're not going to say they're all my favorites, are you?
They're all my favorite images, of course. But I do really like the Christmas tree cluster. So the NGC 2264, I believe that actually refers to the cluster of stars. So we're seeing kind of a cluster in there, mostly like in the lower half. And then at the bottom, you can see that cone nebula that probably a lot of people have seen in other like Hubble images and the big fancy one. So really cool seeing that in here. Though the cluster of stars, the Christmas tree I always see is like upside down, in case you're wondering. With the really bright star is kind of like the stem of the tree. I don't know if other people see it where like the cone would be, that cone nebula down at the bottom would be the stem of the tree, and then the bright star is the star up top, but whatever. You do your own Christmas trees. So the 2264 does refer to both objects. So we have the open cluster of stars, again, being a fairly young group of stars. Some of these might even be proto-stars that don't even have nuclear fusion going on in them yet. And then the cone nebula, again, just like an H2 region, but kind of backlit. So we get some really, really nice details on that. Yeah.
Too many buttons here.
Yeah.
So here's a familiar object, the Andromeda Nebula by Alfredo Vega.
Yeah. So this is probably like really familiar, as you said, M31, also known as the Andromeda Nebula or the Andromeda Galaxy. This is our big sister, big brother in space. Possibly about the same mass, but they're kind of like revisiting that because it looks like Andromeda seems to have about the same mass as the Milky Way galaxy, around 1 trillion solar masses, or about 1 trillion times the mass of our sun. But then it's about 50% larger. So Milky Way having a diameter of about 100,000 light years edge to edge, whereas Andromeda is about 150 million. Just kidding. 150,000. Wrong order of magnitude. So about 100,000 light years across for Milky Way, about 150,000 light years across for Andromeda. Very noticeable dust lanes. You see the companions in there, that little fuzzy M110 and the kind of bright core of M32. Fun fact about this was also the home, of course, of M31V1, which was the first variable, which is a Cepheid variable, discovered in another galaxy, actually pinpointed another galaxy. So that's kind of cool because it helps us obviously measure distances to other galaxies. And they did an update using Hubble heritage data in 2011, got about the same measurements that Edwin Hubble got in 1925. So brother in space, and really great for learning more about the rest of our universe.
Excellent. So here's Caldwell 9, also known as, I can't remember the name of this one. I think Irene might have, done by Garry Schnettler.
Yeah, so I have this listed as Sir Patrick Moore dubbed it the Cave Nebula. And I'm trying to see, I think. So it's about 2,400 light years away in the constellation Cepheus. So same constellation I think the Iris was in. I got that right. about 35 light years across, so a lot of nebula there. Really interesting thing here, it does include both dark nebula and emission and reflection. So we're not seeing so much of the reflection in this image, but all that red, that's going to be a lot of emission nebula, and then a lot of like dust, so just cooler material blocking the light. So kind of the contrast, we have like there's the different kinds there, different kinds of nebula kind of all in one, which is pretty great.
Right. Thor's helmet, also known as NGC 5359. This is by John Williams.
Right. So Thor's helmet, this this is another emission nebula. So about 12,000 light years away in Canis Major, about 30 light years across. And we're seeing reds and blues. So in general, blues are kind of scattering, and reds are kind of emission. We think this might be lit by really fast, and when I say really fast, I mean really, really fast, stellar winds from a Wolf-Rayet star that's in the center. So these Wolf-Rayets could be kind of maybe towards the end of their lifetime, but they're giving off like really, really high stellar winds. So it's ionizing. I haven't been because there was another one in here. Yeah. So potentially ionizing and just exciting a lot of the material in its surroundings. So beautiful, beautiful view of all the gas and dust in the interstellar medium because of the Wolf-Rayet star hidden somewhere in the center.
Okay, another one by Ed Rojas, the M104 galaxy.
Awesome. This is another one I was excited to see because it's one of my favorites. I don't do like super, super dark stuff, but M104, aka Sombrero Galaxy. It's one of the brighter galaxies that I look at, magnitude 8. It's about 31 million light years away in Virgo. It's kind of between Virgo and Corvus. It's not part of the Virgo cluster, but it's a Virgo 2 group, kind of like a little arm shooting off. So it's still part of the Virgo supercluster. So it's in our wider neighborhood yet. Kind of a nice edge-on spiral. Some sources listed it as peculiar or unclear, but with the dust lane, very obvious dust lane that it's kind of known for. And it's very bright, very large central bulge. It's also estimated to have a couple thousand globular clusters, which I'm kind of partial to globular clusters. And it's just one of the brightest, has the its absolute magnitude is one of the brightest in our galactic neighborhood. So very bright, beautiful dust lane, lots of globular clusters in that one.
Beautiful galaxy. So here's the Elephant Trunk Nebula by Alfredo Villegas.
Okay. Elephant trunk. So this is one I wasn't familiar with, so I got to learn a lot about it. So the elephant trunk is kind of part of this whole emission nebula. So sorry, this is another one that's up in Cepheus, about 2,400 light years away. And I think the trunk is like just like technically one little piece, but we're gonna just talk about the whole thing. Yeah, highlighting that. Beautiful. Thank you. So just that piece. So it's IC 1396 is the whole thing, and just that one piece, the trunk part, is 1396A. A probably because it's the most interesting part, is described as a cometary nebule. So basically, this is another thing, kind of like Thor's helmet, only it's not a Wolf-Rayet star in the center blasting gases out, but it's a part of it's a triple star system, and the two main stars that are really close together, have like a 3-day period or something, are both O stars. So it's two super, super bright stars just blasting stellar winds out close to like over 3,000 kilometers per second, which is almost 10 times what our sun does. So just kind of ionizing, exciting, and lighting up a lot of the gas and dust in the medium around it. I was going to say, so there is an open cluster associated with this, Trumpler 37. So they do have like a lot of kind of younger stars in that open cluster that's associated with this nebula. But yeah, really cool, really powerful stars driving this so that we can see all the gas and dust around it.
Right. Here is M51 by John Williams. I think this is also pretty well known.
Yeah, also very well known. Also a favorite for me as an observer. A beautiful face-on spiral with a companion. We'll call it a companion. So this is up in off the handle of the Big Dipper in Canis Venaticis. It's about, how far is this one? Yeah, about 23 million light years out there. So we see a lot of evidence of the interactions of the main galaxy and then the smaller companion. You can see kind of the dust connecting the two, and then kind of the prong that's sticking off, the three-prong bit that's sticking off to the left in this image. So a lot of those features astronomers think may have been caused by two of the previous passes. So we think it may have passed, they may have made two passes in the last like 500 million years or so. And oh, this was the, sorry, I didn't want to get this right from my notes. It was the first galaxy to be identified as a spiral. And that was using, I believe it was the largest telescope at the time, the third Earl of Ross, using the 72-inch 72-inch telescope at Burghcastle in Ireland. So all the cloudy nights, and they were still able to pick this out. So there you go.
Here's M100 by Ed Rojas.
So another beautiful face-on spiral. This one a little bit further away. This is about 56 million light years away over in Coma Berenices. So it's just a few degrees kind of north of Mercurian's chain. So if you're an observer like me and it's a little bit off of Mercurian's chain, like the little kind of coat hanger hook. It is part of the main Virgo cluster. So it gets cred for that. Some people called it like the mirror galaxy. It's probably not so much a mirror since it has more of a central bulge and we have more of a bar. But because it's face on, we can tell a lot of what's going on in its arms. We think there's multiple black holes in the spiral arms, which is pretty cool. And they've been able to resolve some Cepheid variables and looking at some star forming regions. So a really scientifically valuable and beautiful face-on spiral.
Our final image is the Antares region by Alfredo Villegas, and there's several things going on in this picture.
Yes, so there's one in particular I have to talk about because there's a globular cluster here. It's our only globular cluster, so I have to talk a bit about that. But yeah, we have Antares, so the bright orangey star, upper left. So this is kind of upside down and flip from what we would see in the sky. So we have Antares up there, red supergiant, rival of Mars, anti-Aries, Antares. We have highlighted, oh yeah, the globular cluster. I'm going to come back because I want to do that one last. There's the Blue Angel Nebula. That's the IC 4605. Which is the reflection nebula around 22 Scorpii. So I think it's the, I think that's the lower right because it's bluer. So it's supposed to be reflection. So generally with reflection, you're getting scattering. So that's blue light is going to scatter more. And then near, yeah, Sigma SCO over there on the kind of lower left, we have emission and reflection nebula. So you have the emission, the red glowing of like H alpha evidence, and then a little bit of blue you can still see in there around Sigma SCO, which is the Sigma Scorpii. which is that bright star over towards the left. We're actually seeing two globular clusters in here. I can't, if you move it just, yeah, that one. Yeah. So we also have, what is that? NGC 6144 is also there. But I want to talk a bit about M4. I'm going to take a minute. Sorry. This is a really cool globular cluster because most globular clusters have more defined cores. This one, if you see it in a telescope, it's a bit of a mess because it passes very regularly through the plane of the galaxy, and only today I realized just how close to the plane of the galaxy it's passing. It is the closest globular cluster to us, which is why it looks kind of big in a telescope if you're looking at it in a telescope. But can I share? I just want to share really quick. I know we're running short on time, but I want to
go ahead.
This pretty image I pulled up. Oh shoot, am I sharing it? Can you see it?
Yeah, you're sharing.
Okay, all right, great. So the main thing I wanted to point out is over here. I'd always ask myself, is M4 actually on its way in or out of the plane of the galaxy? And the answer is it's back on its way in. But so this is time on the horizontal, distance on the vertical. So it's basically just past its apoapsis. It's just past its furthest point and headed back into the plane of the galaxy. So it never gets very far away from the galactic core. It actually stays really close to the galactic core. If you want to try to think in 3D really quick, you can look at these. But this is the main thing, is like, it's almost as far away as it gets, but it's still like so close. So that's why it's so disturbed, and it's probably been like losing stars over the millennia. But yeah, it's kind of a neat one. So really beautiful image that captures all of that together. The emission reflection nebula, two globular clusters, and some beautiful stars as well.
Awesome. Thank you, Irene. That was great.
Thank you.
We are coming up. We got 6 minutes left. So we're gonna, everybody's had a chance to look over these images, and they've had a chance to think about them. And now you get a chance to vote on your favorite image for our image of the coveted image of the month award. And I'm going to see if I can share my screen, and you guys can look at all the images one more time. And they're going to be numbered, and you can just put your number. If we decide if we're going to do, how we're going to do this, Stan, are we going to do like a poll, or are we going to do it chat, or what?
We're going to experiment with a poll, and I hope this works. I'll launch the poll, and then Preston can show the video of the images.
Okay.
Let me try
You launch the poll first?
I'll launch the poll.
Okay.
And let's see.
Ooh, look at that.
Does everybody see the poll?
Yeah.
So vote for your favorite image after Preston runs the video, and I'll leave the poll out during the video.
And with any luck, we'll be able to see this. Here we go. Okay, pencils down. Everybody vote. How's it looking on the poll, Stan?
Votes are coming in. Vote early and vote often. Let's see, we got 61% participating so far.
It's pretty good.
We'll leave the poll open for a few more minutes.
Okay. There's no voting by mail in this poll.
No, got to be present. So put in your votes, and then we'll update the Gateway Gallery page tomorrow with the winner.
Okay, as long as we're waiting for people to press the button. Any questions? We've seen a lot of images tonight. I do have one question I'd like to hit Irene for, and that is, was it M100? It was the galaxy that you said it had multiple black holes? That was second to the last one?
Yeah, M100.
I didn't know they could have multiple black holes. I thought they, my understanding was most of them just have one, if they have them.
Yeah, so there's different masses of black holes. So we have like stellar mass black holes. It'll be like tens, hundreds of solar masses. There's the missing, like the mystery intermediate mass black holes that we've only kind of recently started to find, like from like tens to thousands of solar masses. And then there's the supermassive black holes. So usually just have one of those, but you can have a lot of like solar mass or potentially even intermediate mass black holes. So we have multiple black holes in our galaxy. Like Cygnus X1, I believe, is like a stellar mass black hole. And then
In our
Sagittarius
galaxy,
are
we have
supermassive.
more than one in our galaxy, you're saying.
Oh,
right?
yeah.
Ooh.
They're harder to detect, but yeah, the big one in the middle is the easy one to find.
Okay. So we're gonna have to be
folks.
careful when we're traveling around in space. Someone else had a question.
30 seconds to vote, and then we'll give you the results.
Cool. David, you're too quiet tonight. You must have a question of some sort.
Is that Dave Kiefer you're speaking to?
Who else?
How did you know? I happen to be in the middle of a course that includes RA and DEC, understanding coordinates. So my question is, if you have an M number or a GC number, I guess you can just put that in and it will go to it right away. But on your scopes, if you put in a RA and DEC number, because you read it somewhere or it's been announced, does the computer automatically change it for the precession number for today? I mean, how accurate does RA and DEC have to be when you insert it into these scopes?
They're all J2000, I think. So I think they're all the precision calculation is pretty simple for modern computers to do. It's not really much of an issue. It adjusts automatically to that.
And for those of you who don't know what RA and DEC means, it's right ascension going up and DEC left, right, basically. Declination. I hope I got that right. So Stan, what's our results?
Looks like we have a tie, just like last time. The Christmas tree cluster and Cone Nebula tying with NGC 2359, Thor's, I think that's Thor's helmet. So John Williams and David Gluchowski have the winning images that we'll post as image of the month for on the Gateway Gallery.
I think the way we resolve this is they go up to North-South Lake on a moonless night and fight to the death. Then how it works, I'm trying to remember.
That's in the rules, yes.
That's in the rules.
Hey, wait a minute.
Congratulations, you guys. I mean, we got to put both of them up, right?
Yeah, congratulations. And one last thing before we leave is especially since John was one of our winners, John and Garry are two of our way out of town members of both the AAA and the Gateway Project. And if you have friends who don't live in New York City, they can still participate in the Gateway Project because it's all online. Everything is done by from your computer, as Alfredo pointed out, from your computer or your phone, whether you're driving or not, you can access the Gateway telescope. So John's from outside of Chicago, is that right?
Yep, don't hold it against me.
No, that's great. That's great. And Gary's from Cincinnati, and they both found the Gateway Remote Telescope online through internet searches. So it's great that you found us and joined the AAA and are participating. So Ed Rojas is a longtime AAA member. He lives in London, so he's been doing his processing from London. And so So we've got people all over, and it's a great thing about the remote telescope is you can have people in different places and be able to have a successful look at the what's out in our universe.
Yeah, I just want to say about this project that we just started it up late November. This has just added a whole new dimension, a whole new. It's opened the aperture, if you will, on what AAA Astrophotography can do, in the sense that here in New York City we have a certain kind of sky and we can do a lot with it, and we can go a couple hours out of town and do a lot more with darker skies. But these remote scopes now, well, this package is just such an unbelievable deal for us. It's such a steal for anybody who's interested in remote electronically assisted astrophotography. So this is just the coolest thing. And now we're looking at another scope below the equator, which could be really exciting too. So so stay tuned, and please let us know your thoughts and your what you like to see and what you like and didn't like, and support the scope, this project, because we can use your support to make these things happen. So we really appreciate y'all being here tonight. Anybody else want to say anything? Alfredo?
No, it's great. I mean, again, like, we really need your help in terms of just volunteering. We happy if you volunteer, we'll give you a free data subscriber membership just for helping us out. So that's a little bit of a carrot, hopefully. But we really do need help, especially if we're going to do this Southern Telescope project. Not only do we need people willing to contribute to support it financially in terms of being operators or being target selectors, but we also need people to help out in terms of just helping to administer the data, because it's, as I said, we're probably going to be a terabyte of data by the end of the year on this telescope. And then next year, if we operate the Southern Telescope, we'll operate this telescope as well. So we'll have two telescopes. So potentially that could be twice as much data. And right now we're kind of ripping our hair out just trying to manage what we have. So we really need help, and we really appreciate people, being willing to help us out.
I just want to say about the scope we're considering now is Antoine Ribot's scope, and it's located in Chile, and it's one of the darkest skies on the planet. And so, if you think the Texas images are cool, I mean, these are going to be amazing as well. It's just such an amazing opportunity. And if you know Antoine at all, you know that he's going to have, let's see, it's a technical term, a kick-ass scope. I mean, this thing is really just amazing. So we're hoping that we can put this together and further open the possibilities for the club. We think it's very exciting. All right, with that, thank you all for coming tonight. We really appreciate it. Go back and think about what you've done, and thank you all for coming.
Thanks, everybody.
Well,
Thank you. Thanks so much.
Great program. Thank you.